Howdy, folks. I don't know what brought this Radio Shack Sun and Sky monitoring station to my attention here recently. I did go online trying to find some information about it, and there was almost nothing out there, very little. The unit was actually designed by a guy named Forrest Mimms, who's best known for his electronic circuit books that were published through Radio Shack. And he also did a whole bunch of amateur science work with instruments that he designed and built himself. And this kit actually has one that's almost very similar to that. In fact, you can find plans for circuits that are almost identical to the one in the kit from his books. I do have his 4 set of books that are still available nowadays. And I decided to just go ahead and buy the unit. As far as my interest, I was just kind of curious, and also I was interested for possible other applications for kind of the electronics, maybe not even dealing with the atmosphere. I do have a video about a homemade calorimeter that I made, and the theory and application is very similar. This actually looks at light of different frequencies coming through the atmosphere. And the calorimeter that I built looks at the light of different frequencies going through a liquid. It is about impossible to rate or grade this item for everybody that's going to watch this video. The one thing you need to remember is that this is an educational tool, even a scientific instrument, but it's not an entertainment device. And it requires quite a bit knowledge of math and science. To get everything out of it, you're going to need to know some basic arithmetic. You're going to need to know how to calculate ratios and understand what they mean. You need to calculate XY graphs and plot the things on a graph. You need to know how to take the natural log of a number and the inverse log, or e to some power, on a calculator. And there's even a little algebra would help. He mentions the sine function somewhere, which is trigonometry. Having said that, you wouldn't want to give this to a 10-year-old and expect them to run off and have hours and hours of fun and laughter and excitement with it and come back as a budding scientist. However, if that same 10-year-old might find this really fascinating if you work with them on it and explain some of the hard details and some of the math. My personal rating is an A. I really got a lot. I learned a lot about the sun, the atmosphere, and even about time. So your rating is going to be based on your personal interest. You may not even find this at all interesting as far as the subject matter when you start looking at it, and also your expectations about what the unit is. Here's the box. I'm going to include a couple of still pictures that are a little bit closer. Right on top is the manual. Like I read on the cover, it's 64 pages, and it has 5 chapters or units. The first 3 involve actually collecting data and doing your own measurements. The last 2 are more informational. They cover stuff like the satellites that are out there that do monitor the atmosphere, and some projects that you can do. But it's actually very in-depth. It covers a lot of theory, wiring diagram, and it has charts for filling in your data. So I actually photocopied these and filled them out on my own. It's a nice book too. It's well bound, very nice manual. The next thing that's in here is a filter, and this is really not all that important for the unit. Basically, it's a demonstration to look at a hazy sky with different color filters and seeing the improvement after you take away some of the haze. And that's the only time it's referenced. So if you go to buy one of these units and it's missing the filter, don't worry about it. It's not a big deal. What else is included is a bag with different resistors and a couple of capacitors. You install them on the front on these springs. It's very easy to be mistaken that there is something about electronics. It really has nothing to do with electronics. What the reason the resistors are here is these are gain resistors, and every unit is different, and every resistor is different, and you want to put the right value to get a right range out of your meter here. By putting in a physical resistor rather than having a knob, you can be sure that you're getting repeatable numbers. You change the knob and want to switch it back, you're never going to get it into the right spot. So if you're doing long-term comparative studies, you want to use the exact same resistor for each one of these sensors. What you want to do is once you find a resistor that works for you in the right range, label it for the color of light that you're using and keep that for storage. So if you do need to remove it and you want to go back and get comparable numbers to what you're looking at an earlier study, you can reinstall that resistor. So this is a very good design feature where he keeps the integrity of this unit as a measuring device and scientific instrument. So that was impressive. In fact, everything about the meter itself is impressive. It's a very well thought out unit. Everything is here that you need to go out and take measurements, other than maybe a piece of paper and pencil to write down some numbers. But you want to have the unit level, so it has and aligned, so it has a compass and a level bubble level here. It has adjustable feet on it. All the gizmos have little spots that they actually fit into, so you don't lose any parts and pieces. It has a power switch, a selector switch for the 4 different sensors that you have. It even has an output if you want to record it to a chart recorder or something, or use a different meter, and an output meter. Plus there's even a scale for measuring the sun angle here, and a shading device. So it's a very, very well designed and well made item. Now let's take this outside and actually see it in operation. We have a beautiful sunny morning here. My setup is just basically this table, and what I've done is I've blocked it up to stabilize it and also to level it, and you can adjust the feet to level that out, so I've done that in advance. And you also want to align the back of the unit here with south, and we have a compass. Now to take a sun angle and air mass reading, what you do is you take the unit and you face it directly towards the sun. I'll move it over a little. You see there's a shadow here, and I line it right up along this line so I know it's pointed directly at the sun. And basically this lip casts a shadow, and I don't know if you can see, but there's a scale here. One side reads air mass and one side reads sun angle. So right now the sun's about 20 degrees and the air mass is 2.9, so we're going through the atmosphere about 2.9 times the atmosphere compared to going straight up. As far as taking readings, the first thing you do is take off this diffuser shield, and we'll take a reading as a radiometer. And to do that, you want to have the unit facing south. Like I mentioned, you turn on the power switch, and that's about it really. You put the selector switch on whatever color LED you're going to use, or in other words what frequency you're going to look at, and you measure the output on the dial here. Might be hard to see for you, but that's this is green, red, the one infrared wavelength and the second infrared wavelength. So that's pretty straightforward. When you're using the unit as a radiometer, you can take a direct sun reading like this, and you can also use the sunshade, and you lift it up and cast a shadow onto the sensors and take readings from indirect light. To use the unit as a sun photometer, you take the collimator here, and it's got 4 holes that line up with the LEDs. You want to shine the light straight through the hole right to the LED, and you clip it in, and there's actually a crosshair right here, and it's in the plastic, but I put a little bit of black marker on there so it's easier to see. But you take the unit and you direct it directly at the sun, and what you do is you try to get the shadow of this hole to line up with that X. And when you've done that, the light will hit each of the 4 LEDs in a direct line, and then you can take a reading. Let's go over some of the activities and exercises and experiments here in the book. The first one is a cloud effect experiment. Then he has you plot the sun over a period of time, and you get this nice curve in the morning. As the sun rises, it increases in level and then decreases on the way down. There's also some studies on things like looking at light that's used for photosynthesis. The red sensor is a frequency that plants use to do photosynthesis. And then he also has some experiments here with the sun angle and air mass. This one's interesting. You take a whole bunch of data and then you plot it on a logarithmic scale. So instead of getting the curve that we saw, this is actually a straight line when it's plotted as a log. And it's plotted against the air mass, which I explained before. But being linear, you can actually extrapolate out and find out what the amount of light is at an air mass of 1 if the sun was totally above you. And you can also look at what the solar radiation would be at an air mass of 0. So that implies that you're looking at it from the very top of the atmosphere. So you're just at the edge of outer space. So that's kind of interesting. You actually measure this, what he calls is an extraterrestrial constant. So the one thing you want to keep in mind, though, that he says is this intercept is the ET constant. But actually, any references or equations that he has in there, he's talking about the ET constant voltage. So you don't use the intercept per se, but actually the inverse log of the intercept, which would give you a voltage number. So he's not really clear about explaining that, so you want to keep that in mind when you do this. Other activities include stuff like measuring haze. Here you do that with the shadow band, where you measure the sun directly and then you cover the direct light and just see what has been scattered through the haze. And he actually has some pretty complicated calculations for measuring what's called the optical thickness from aerosols, which contribute to a haze. But he does do a pretty good job of going with a basic equation, then he adds in different factors and tries to explain exactly why you're adding stuff in, and does have a worksheet here to do that. Measuring water vapor. This exercise, you actually get a curve, and you can actually calibrate this by getting data either online or actually making an estimate by knowing the dew point. So you can get a value for what they call precipitable water, or the amount of water in the atmosphere above you. So you can actually find the precipitable water in centimeters by using the meter. And here are some of the projects that they mention that you can do. You can do studies with clouds, different time periods, looking at faraway places if you go on vacation somewhere far away, doing comparisons, looking at plane contrails, those lines in the sky, effects from forest fires, looking at under a forest canopy, the light that's there, different dust storms, comparing it, doing different calibrations and comparing it to satellite data, volcano eruptions, biological material that may be in the air that affect the light, and air pollution. Let's see, there's some more complicated data and a glossary, and also a generic data sheet that you can copy and use to collect data for your own project. And also answers to the exam questions. The first 4 chapters have a little quiz in the back of looks like 10 questions each. That makes sure that you're picking everything up and understand everything. Well, that's it. As I mentioned, the unit is very nicely designed. I learned a lot out of it. You do have to be careful if you give this to a child that doesn't have the math or science background, that he's within minutes he's going to be totally bored and lost and confused on the whole thing. But that doesn't mean you can't work with them on it and kind of explain things and do some of the projects with them. As far as long-term use of this thing, I do have a project in mind that involves using it over a growing season. Other than that, I'm not sure if I'll get a lot of repeat use out of it. It would be kind of interesting to, when you're outside, you see a day that's, oh, this is such a clear day, you can actually pull this thing out and do a haze measurement and say, yeah, that was pretty clear, but there was a clear day that day back in June, or you know, it looks really foggy or smoky out, or hazy out, and you can look at you know, take a measurement and say, yep, there's something in the air here that's a little bit different. They're higher than normal. Well, thank you for watching the video. I hope you got some information out of it. And happy sun and sky monitoring to you.